Okay, so the unit circle. This is going to look like a lot. A lot goes into the unit circle, but it's really quite simple. And we'll talk about more of the patterns to find it next class. But right now, we're just going to talk about the basics on how to find all of these things. All right. So the basics of the unit circle. They call the unit circle because the radius is one unit, exactly. So let me hit select. There you go. All right. So the radius is exactly 1 unit. What the fleck is a radian, Miss Fleck? A radian is when the length of the radius equals the length of the arc that it cuts off. That's what a radian is, right? Why do they have that? Still, Angelo, that's just one of those deep questions. All right. Radian is when the radius, the length of the radius equals the arc. When you put 2 radii together, because these 2 are equal, right? It equals the length of the arc. Notice the arc is curved, so there's some special magic there. Yeah. All right, here we go. When you think about the unit circle, first of all, it's kind of like the xy coordinate where the origin is in the middle, so this is 0, 0, and the xy coordinate, right? The coordinates of all of these things just coordinate with x and y, so this would be like 1x, 0y. Yay? Go ahead and apply all the coordinate stuff. Okay, now, as you can see, these coordinates right here separate the unit circle into 4 quadrants. True? So in this first quadrant, everything in this quadrant will have a positive x value and a positive y value. The first quadrant's always like that. Yay? So it's positive x and a positive y value in quadrant 1. And if you'll remember from Algebra 2 or wherever you learn this, the quadrants go clockwise or counterclockwise? Counter. So quadrant 2 is right here, right? And in this case, the x values are negative, but since it's still above 0, the y values are positive. Okay? And continuing on clockwise, in quadrant 3, both the x and the y values are negative. Yeah. And in quadrant 4, x value is positive, but the y value is negative. No big mystery there, right? Okay. All right. So again, just to emphasize, the central angle of 1 radian is when the arc length is equal to the radius. So the arc length is 1 and the radius is the same thing. There you go. That's what that's supposed to look like. Okay. Questions so far? All right. So that's kind of the basics, the foundations. Now we're going to move on to how to find all the coordinates in the circle. All right. Here we go. Again, in a unit circle, we have a radius of 1. Yay. Now, when it comes to sine and cosine, I should say, here we go. When it comes to sine and cosine, remember SOHCAHTOA, right? Yeah, here we go. In SOHCAHTOA, sine is equal to the opposite, thanks, opposite, oh, hello, opposite over the hypotenuse. Oh, sorry. Right? Sine is equal to opposite of hypotenuse. So from this angle right here, let me use the select. Okay. Yeah. From this angle right here, the side that's, I'm sorry, nope, go away, this one. There you go. The side that's opposite from this angle is over here, right? And then the radius that is the hypotenuse is 1. Notice that the sine is the y-axis, right? It's the y-coordinate. So that's why in just basic trig, sine is the y coordinate. Yay. Cosine is going to be the x coordinate because cosine is adjacent. Yeah. Cosine is adjacent over the hypotenuse. And again, since the hypotenuse is 1, the adjacent angle right here is just cosine over 1, or just the x value over 1. Right? And then TOA, of course, is tangent is opposite over the adjacent. Right? So if it's opposite or adjacent, then in trig, tangent is the sine over the cosine. Or if it helps you even better, Tropical Smoothie Cafe, because tangent is sine over TC. No, TSC? No? Okay. Tropical Smoothie Cafe. Yeah. Tangent is sine over cosine. That's a pretty basic trig identity right there. Hi. All right, here we go. Since there's a right triangle, then we have the Pythagorean theorem. So we all know that a squared plus b squared equals c squared, right? Right? So on our picture over here, since the cosine is x, let me use a pen, right? Since the cosine is x and the sine is y, then x squared plus y squared equals 1, or r squared, right? 1 squared is 1. So the big trig thing, this is like the Bible of trig right here in one sentence, is that cosine squared, sine squared plus cosine squared always equals 1. Right? And that's just based on the Pythagorean theorem. Questions so far? Has anyone never seen this before? Do we see this in geometry? You see it in algebra? Last year in algebra 2? Math analysis. Math analysis, yes. Algebra 2, did she get to it? She did? Excellent. I love you, Craig. All right, here we go. Ish. Yeah. All right, here we go. The two big triangles. Right? Everything comes from your two main right triangles. The first one, of course, it is a right triangle, is an isosceles right triangle, and that's the 45, 45, 90. Yeah? Okay. So, since it's isosceles, that means the left equals the right. Yay?
Part of this interruption, teacher, if you haven't done so already, some of those questions.
Thank you, Jesus. All right, here we go. All right, so in the isosceles right triangle, first of all, the radius is always the hypotenuse, so we know this has to be 1. Yay. Right? So, since these two sides are equal, okay, since these two sides are equal, then they could both be x, right? So it goes x squared plus x squared equals 1 squared, which is just 1. So you got 2x squared equals 1, and x squared equals 1 over 2. When you take the square root, it's going to be x equals 1 over root 2. Yay? Okay? But we have to rationalize. Does anyone know what 1 over root 2 is? It's root 2 over 2. Yeah. So this is root 2 over 2, and this is root 2 over 2. That's, I mean, basic right triangle geometry right there. Okay. So if remember, the sine is the, hello? Yeah, but the sine, is that the x or the y? It's the y. So the y value is the one going up and down. So sine at theta would be square root of 2 over 2. Yeah? So the cosine would be, again, it's the x. Yeah, square root of 2 over 2. Tangent is the y divided by the x, and the sine divided by cosine. What's the number divided by itself? It's 1. Yeah. Yay? Okay. Second right triangle that is special. Anyone? Yes! Okay, would you believe that the first year I became a math teacher, I bought a house. In my house, I had like an actual like telephone line, and my telephone number was 360-6090. Meant to be. All right, here we go. This is 30 right here. Let's say this one was at 30, and this is 60. Yay. All right. In this case, this is a 1, right? And when it comes to a 30, 60, 90 triangle, it comes from an isosceles triangle. No isosceles. But all the sides the same. Equilateral, equilateral, right? Equilateral, let's say all the sides are 1. That means when you cut in half, this is 1/2 right here, right? So this is the 1/2 side. Yay? So x squared plus 1/2 squared is equal to 1. So x squared plus a 4th is equal to 1. Yeah? Take away 1/4, x squared is equal to 3/4. When you square root both sides, x is equal to root 3/2. Hey! So this part right here is root 3/2. So here's the deal. How are you going to remember this? What's bigger, 1 or root 3? The square root of 3, right? Because the square root of 1 is 1, so that means anything bigger than the square root of 1 has to be bigger than 1. True. So the root 3 is across from the bigger angle. So the root 3/2 is across from the 60, and the root 1/2, sorry, the 1/2 is 30. Yay? Okay. Here we go. So in this case, if the sign, I should say, because there's different ones. There's the sign at 60. So if you're doing at the sign, I'm sorry, the sign at 30 degrees is going to be the y. Yeah, let's do this. The sign at 30 degrees, because there's a difference between sine 30 and sine 60. The sine at 30 degrees is 1/2, yeah. The cosine at 30 degrees is root 3/2, yeah. Okay, I'm going to do this. And yes, okay. This is root 3/2, and then the tangent is going to be almost, yeah. So it's the sine over the cosine, right? Yeah, okay, so let's take a look. So it's 1/2 over the square root of 3/2, true? Okay, so the 2's cancel out, and it's going to be 1 over root 3, which is root 3/3. Yeah. True? Okay, notice this is the sine, cosine, tangent at 30. If you were to go the other way and the 60 would be on the other side, the sine and the cosine and tangent would all just be flipped. And we'll go over that one after. Yeah, we'll do it on the unit circle because I'm out of space over here. All right, okay. So now we go to here. Whew. All right, there we go. When it comes to the unit circle, start with the easiest right triangle, which is the 45s. Okay. Bum, bum, bum. All right. So at 45 degrees, yay, the y and the x are root 2/2. Yeah. So the coordinates at that point would be root 2/2, comma root 2/2. That's the x, not the y. Yay. Okay. Okay. Here we go. The next 45, so right here would be 90, right? And we already know that the coordinates 90 are 1 and -1. Right there? Yeah. So we should already have this one. At 90, right here, the coordinates would be, 0, 1. Yeah, 0, 1. Oh, so 1. Okay, that's a 0, 1. Okay, here we go. Then 45 degrees later, you're at 135. Now, here's the beauty, the pattern of the unit circle. All the 45s have root 2 over 2, root 2 over 2. But where they are in the quadrants determines their sign. Is it positive or negative? So in the second quadrant, which one's negative? Yes, the first one. Right? Okay. 45 degrees later, we're at 180, which is negative 1, 0. Is that right? We already have that one. And 45 degrees later, we have 225. Yeah. Okay. Again, it's still root 2 over 2, but which one's negative? Both! Oh, goodness. They're both negative over there. Yeah? Okay. 270. Then we go to 350. Yes. All right. And which one's negative at 350? The second to last. Okay. The only thing we haven't gone over yet, other than the 3690, we'll get to that part, is how to convert it to radians. Okay. Here we go. To convert an angle to radians, right? First of all, you know that the circumference is 2 pi r, correct? Which means all the way around is 2 pi. That's why this thing right here, 360, is 2 pi, because that's the distance around the circle. True? Right? Okay. So to find each distance between the radian, where's that? This one. Oh yeah. To find the distance between the radians, you just multiply the degrees by pi over 180. So to convert, you just take the degrees, maybe 10, yeah. Okay, so whatever you have in degrees, just multiply that by pi over 180 to convert to radians. That's it. So, for example, if you take 45, let me extend this page. Hang on. Let's see. Select. Okay. So if you want to convert 45 degrees to radians. Okay. So 45 degrees times pi over 180 reduces down to, keep it in pi. How many times does 45 go into 180? 4 times, yeah. So we know that cancels out. This becomes a 1. So it's just pi over 4. Make sense? So the radians at 45 will be pi over 4. Yay? Okay. You would just do the same thing with 90, 135, and 180, and they will all reduce down to a simple fraction. 90 is pi over 2. 35 is 3 pi over 4. This is in radians. 180 is, if all the way around is 2 pi, what's halfway? 1 pi. Yeah. And then 5 pi over 4. What do you think 270 is? Yes! 3 pi over 2. And then 7 pi over 4. Okay? Do you see a pattern yet? Okay. The 45s are all over 4s. They're all over 4s. So that's not, they're just reduced. They're simplified. 0 pi over 4. 2. 1 pi over 4. 2 pi over 4. 3 pi over 4, 4 pi over 4 is pi, right? 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4 reduces down to pi over 2. So you can just count by pi over 4s on all the 45s. Right, okay. Okay. If not, you can also just multiply and get and just figure it out by using the multiplication part. Okay? Yeah. All right. Whew. Do we need to take a stretch break? We good? I think we need a break. Hang on. All right. Here we go. Finishing up the rest of this unit circle, okay? Between the 90s, you have a 45 halfway, and then every 15 degrees or so, 30 degrees or so, there's a 30 and a 60. So your 45, again, is like right over here, and then the two on the side are 30s and 60s, or some multiple of the side of the kind. So there's 30 degrees between all of those angles. Yay? Yeah, go ahead and fill in the angles. I'll give you a second. Okay, let's start with coordinates. Here we go. In a 30 degree angle, right, if you'll recall, yeah, the x coordinate was √3 over 2, and the y coordinate was a half. So, of course, that would be your x coordinate. Okay? Now, imagine all the other places that this could happen where the x is √3 over 2 and the y is 1/2. What other degree would have the same value as 30? 150, exactly. Since 150 is on this side, it's going to be √3 over 2. Negative √3 over 2 instead of just √3 over 2. Right? If you're still not sure what we're looking at, it's 30 degrees away from the x-axis. So this is 30 degrees away right here. This angle right here is 30 degrees away. Okay? What other angle is 30 degrees away from the x-axis? 210. Definitely 210. And this time again, both of them are negative. All right. Here we go. And the other thing that's 30 degrees away? 330. 330. Yes. Okay? All right. Now take that triangle and flip it on its side, and that just switches the x's and y's. So the 60 is the same as the 30, just flip it around. So 60 degrees will have coordinates of a half and √3 over 2. I know. Yay? Okay. 120 would be the same thing, just flipped around. Then 240. Question, why are there exactly 239 beans in the Irish soup? Because one more to be 240. All right, here we go. All right. I just want to make sure you're awake. Okay. Yeah. You're so terrible. So, thank you.
I'm Irish. I appreciate that.
Shucks. All right. We shall celebrate St. Patrick's Day together. There we go. All right. So the same thing again if for converting to radians, right? Since 1 radian is 180 degrees, to get 30 degrees into radians, just multiply by pi over 180, and it's pi over 6, right? And then 60 is pi over 3. So, here we go. Again, you have this one. This is pi over 6 and pi over 3. Okay, the smallest of those is pi over 6. So if you count every 30 as pi over 6, you're good. For example, this is 0 pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6. True? Because 3 over 6 reduces down to 1/2. 4 pi over 6 reduces them. 5 pi over 6 is what it is. And 6 pi over 6 is just pi. Right. Okay. Then we have 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. And 12 pi over 6. Yeah, it's just like a clock. That's it. Just go around. Just go around. Okay? By now, you should have like a pretty full circle. Oh goodness. Oh goodness. Take a look around at your neighbor's circles. Some of them are like neat and to the point. Other ones are like, what? But as long as you know what you're doing, I'm good with that. We're good. Yay? All right, let's see what's behind this mystery box over here. Oh, Pythagorean theorem. Yeah, they talked about that. Okay. Yay? Okay. So, how are you going to remember how to do this? Oh Lord. Your completed circle should have all of these parts to it. Okay? Yeah. Oh, I'm just gonna keep on. Yeah, whichever. It should all be complete, right? Yeah. I feel like Vanna. Alright. That's kind of nice, especially since the microphone's over here. So I missed a couple, didn't I? Okay. All right. Here we go. Even though you have to be able to fill in the whole circle, if you can just remember the first quadrant and use your left hand. Does everyone have a left hand? Oh, good. Here we go. Put your left hand on your unit circle. All right. Left hand. Here we go. The thumb is 0 and the pinky is at 90, right? And then you have 1, 2, and 3. Ready? Here we go. Hey girl, what's your sign? It must be 90 because you're the 1. No! Okay, the sign of 90 is 1. Alright, here we go. So start with sine. Alright. For the first thing, 30 is root 1 over 2. This was the square 1. It's 1. So if you start with sine, this is 1 over 2 root 2 over 2 root 3 over 2. Right. And then just work your way back down. 1 over 2, 2 over 2, 3 over 2 for your two sides. Once you have that figured out, just that section, all of this is easy to fill in because you just change the signs around. There you go. All right, so let me put this down. Here we go. All right, your job today is to recreate this circle from scratch. What I would